Let's look at an example of a perfectly inelastic collision. And what this means is that the two colliding objects actually stick together and move with a common velocity at the end of the problem. And one of the interesting things about inelastic collisions is that you will always see that there's some energy missing by the end of the collision. So we're going to actually calculate that in addition to getting the final velocity. So we start this out by saying P initial must be equal to P final. And that's because the net external force on this system is 0, and both of these objects just experience interaction forces between them during the collision. Now you might complain that, well, gravity's pulling down, but the normal force is pushing up on each of these with exactly the same magnitude as the weights, so the net external force is 0, and momentum is conserved. So we'll look at the momentum in the initial state. And all I have is this one moving object. So that's 2 kilograms, 3 meters per second, just mv there. And then in the final state, well, these are both moving with the same velocity. So I have 3.5 kilograms moving with a final speed of vf. So solving for vf, I take 6 divided by 3.5, and I get 1.71 meters per second. So that was quick. Now let's look at the energy lost in the collisions. So I'm going to look at the initial kinetic energy. K initial is 1/2 times the mass that was moving and the speed of that mass squared. And I end up getting 9 joules of energy. When I look at the kinetic energy in the final state, I have 1/2. There are 3.5 kilograms of mass moving along at 1.71 meters per second. Make sure to square that. And I get a final kinetic energy of 5.12 joules. So if I look at K final minus K initial, I could tell you how much energy was lost. So negative 3.88 joules, or I could say 3.88 joules was lost. 3.88 joules lost. So this always felt a little bit weird to me because we didn't seem to put anything into the problem that allowed energy to disappear. But it turns out that for two objects to stick together and conserve momentum at the same time, there is no other option but to have a little bit less energy than what you started with.